The CPU is one of the most important components of a computer system. We will explore how a CPU actually works and what happens inside it. The CPU is a complex electronic circuit that consists of several components. At the highest level, the CPU architecture consists of three main components: the control unit, the arithmetic and logic unit, ALU, and the registers. The control unit is responsible for fetching instructions from memory and executing them. The ALU performs arithmetic and logic operations on data. The registers are small, high-speed storage locations within the CPU that hold data and instructions. The instruction cycle is the process by which the CPU fetches, decodes, and executes instructions. The instruction cycle consists of 4 stages: fetch, decode, execute, and store. During the fetch stage, the CPU fetches an instruction from memory and loads it into a register. During the decode stage, the CPU decodes the instruction to determine what operation needs to be performed. During the execute stage, the CPU performs the operation specified by the instruction. Finally, during the store stage, the CPU stores the result of the operation in memory or a register. CPU pipelining is a technique used to increase the throughput of a CPU. Pipelining allows multiple instructions to be processed simultaneously by dividing the instruction cycle into stages and processing multiple instructions at the same time. The instruction cycle is broken down into multiple stages, and each stage is processed separately by different parts of the CPU. By processing multiple instructions simultaneously, the CPU can achieve higher throughput and execute more instructions in less time. There is another part of CPU called cache memory. It is a small, high-speed memory that is used to store frequently accessed data. The purpose of cache memory is to reduce the time it takes for the CPU to access data from memory. There are different levels of cache memory, with L1 cache being the fastest and L3 cache being the slowest. L1 cache is located on the CPU itself, while L2 and L3 cache are located on the motherboard. Clock speed is one of the most important factors that determines the performance of a CPU. The clock speed of a CPU is the rate at which it can execute instructions. It is measured in gigahertz. A CPU with a clock speed of 2.5 GHz can execute 2.5 billion instructions per second. However, clock speed is not the only factor that determines the performance of a CPU. The number of cores and the instruction set also play important roles. A CPU with more cores can execute more instructions simultaneously, while an advanced instruction set can allow the CPU to execute more complex instructions in a single clock cycle. The CPU is a complex electronic circuit that is responsible for executing instructions and performing calculations in a computer system. We hope that this video has given you a better understanding of how the CPU works and what happens inside it. Thank you for watching.